Hello guys, welcome to this channel. Please make sure you subscribe, turn on the notification button and share this with your friends. Now in this video we are going to look at some integration questions and prefer solutions to them. Now to begin, let's take question 1. Now question 1 says that integrate, you have the sign of integral, integrate 1, sorry about this. Okay, the first question says integrate 1 over 2x plus 5 dx. Now you are given to integrate 1 over 2x plus 5 dx. How do you integrate this? You integrate this by substitution. By what? Substitution. Okay, now what you are going to say is let everything under be equals to u. So we can say that u is equal to 2s plus 5. Now if u is equals to 2s plus 5, differentiate u with respect to s. That is the next step. The next step is differentiating u with respect to x. Now differentiating u with respect to s, what are we going to have? You have du over dx is equals to, when you differentiate 2x it will give us 2, plus when you differentiate 5 is going to give us 0. So our du over dx is equal to 2 plus 0 is what? Is 2. So du over ds is 2. Now remember that we substituted u for what? 2s plus 5. So our equation can also be, or our expression can also be written as one integral of 1 over, in place of u we can put the value of, or in place of 2s plus 5 we can put in the value of our u. So this is u dx. Now recall that your du dx is equal to 2. Now can we make the s subject to the formula here? Yes, we can make the s subject to the formula, knowing that du over ds is equal to 2. This is over 1. Cross multiply 1 times du will give us what? To give us du is equals to 2 ds. Now to get ds, divide both sides by what? 2. 2 cancel 2. ds is du over 2. So in place of ds we can put du over 2. So this will give us the integral of 1 over u times, in place of ds what can we put? Du over 2. So this is du over 2. Okay, now we can separate these two to become integral 1 over u times 1 over 2 du, because 1 times du will give us du, then 2 times whatever here will give us what? 2. So this half here is a constant, is what? A constant, hence we can take it out of the integral sign. So half is out. We now have 1 over u du. Now when you differentiate, integrate 1 over u, du is going to give us the absolute value of u. Okay, so this will be half times the natural logarithm of the absolute value of u plus c. So this gives us half times ln. Now what is our u? Our u is what? 2s plus 5. So this becomes 2s plus 5, okay, plus c, and our final answer would be equal to, final answer is half ln, then we have 2s plus what? 5 plus c. Okay, so that is the answer to this question. Let's take the next question. The next question says integrate. Now we are going to follow the same approach. Okay, integrate 3 all over 4 minus 2x. Now first of all, what do? We make u substitution. Okay, so making u substitution, your u would be equal to 4 minus 2s. Let u be equals to what is under here, okay, to simplify it. So differentiate u is the next step. So differentiating u, what are we going to have? You have du over dx is equals to, when you differentiate 4 is going to give us 0, differentiate minus 2x is going to give us what? Minus 2. So du over dx is 0 minus 2 is what? Minus 2. Okay, so our du ds is minus 2. Okay, so therefore wherever we see u, we can put in the, or wherever we see 4 minus 2s, we can put in what? U, because we said that u is equals to 4 minus 2s. So making that substitution here, what are we going to have? You have integral of, this becomes 3 all over, wherever you see 4 minus 2x, which is this 4 minus 2s, what are you going to put here? You put in the value of u. Okay, put in the value of u. So our something now is integral of 3 over u dx. Okay, now you know that du ds is what? Minus 2. So if du over ds is minus 2, make ds subject to the formula. First of all, let's cross multiply. 1 times du will give us du is equals to minus 2 times ds will give us minus 2 dx. Okay, so divide both sides by minus 2 to make ds the subject of the formula. When this cancels, your ds will be what? Du all over minus 2. Okay, du all over minus 2. So wherever you see ds, you can put du all over minus 2. So coming here again, we said this is what? Integral of 3 over u times, in place of what? ds, now we can now put what? Du all over minus 2. So this becomes du over minus 2. Now 3 is constant, or we can write this 3 as something like this: 3 times 1 over u times what? Then we have 1 over minus 2 times what? Du. Okay, we can bring 3 out. If you bring 3 out, it gives you 3 times, you can bring minus half out, or 1 over minus 2 out, which is what? Minus half. Then we have integral of 1 over u du. The reason why we brought all these ones out is that they are constant, they don't have any variable attached to them. So this gives us 3 times minus 1 is what? Minus 3 all over 2, then integral of 1 over u du. Now 1 over u is what? When you integrate 1 over u, I told you that this is going to give us ln, or the natural logarithm of the absolute value of u plus c. So this gives you minus 3 over 2, then ln u is what? 4 minus 2x and everything plus what? C. So the final answer to this question is what? Minus 3 over 2, the natural logarithm of 4 minus 2x, then plus c. So this is the final answer to this question. Okay, let's look at the next question. The next question says sec square s tan x ds. Integrate this. Integrate sec square s all over tan s, then what? ds. Now we are still going to make u substitution. Let u be equals to everything under. So let u be equals to what? Tan s. So we say let u be equals to tan s. Then the next step is to differentiate u. So if our u is equals to tan s, first of all, we're going to write the expression again. So this becomes what? Sec square s all over. In place of tan s, we can put what? U, and this becomes ds. Okay, so now our u is tan x. Differentiate u with respect to s, so this becomes du ds. When you differentiate tan s, what will it give to you? It will give you sec square s. Okay, when you differentiate tan s, it will give you sec square s. Now at this point in time, we can make the s subject of the formula. Okay, we can make the s subject of the formula, knowing well that our du over dx is equals to sec square s. This will be over 1. Cross multiplying 1 times du will give us what? Du. This is equals to sec square s ds. So to make the s of the formula, divide both sides by what? Sec square s. Divide both sides by sec square s. Sec square s cancels sec square s. The s is du all over sec square s. Okay, the s is du all over sec square s. So integrating the our value now is now what? ds is equals to du all over sec square s. Now substituting in here, what are we going to have? Now we know that this is, we have sec square s all over u times ds initially. Okay, that is this ds here. Now we already know that ds is what? Du all over sec square s. So this gives us sec square s all over u times ds is what? Du all over sec square s. Now note, when you differentiate tan s, is going to give us sec square s. Okay, that is a constant. So this sec square s cancels sec square s. What are we left with here? We are left with 1 over u, then what? Du. 1 over u du. Okay, so this is 1 over u du. Now if we integrate this, when we integrate 1 over u, it will give us what? Ln the absolute value of u plus what? C. Now what is our u? What substitution did we make for u? We said u is what? Tan s. So this becomes u is equals to tan s, and then this becomes the natural logarithm of tan x plus c, and that is the answer to that question. Natural logarithm of tan s plus c. Now let's look at the next question. The next question says integrate 2s plus 4 all over s squared plus 4s minus 1. 2s plus 4 all over s squared plus 4s minus 1. Now how do we go about integrating this? How do we go about this? We can go about this by also making the u substitution. Okay, let's say let u be equals to s squared plus 4x minus 1. Then when you differentiate this, it's going to give you du over the x is equals to differentiate s squared to give us what? 2s plus differentiate 4s, it will give us what? 4, then minus 0. So du over the x is what? 2x plus 4. Now at this point in time, we can make the x subject to the formula. So we have du over the x is what? 2x plus 4 all over 1. We can cross multiply this times this, it will give us du is equals to 2x plus 4 times what? Dx. So we have du is equal to 2x plus 4 times dx. To make dx subject to the formula, divide both sides by 2s plus 4. 2s plus 4, and this cancels this. Your ds is du all over 2s plus 4. Okay, ds is equals to du all over 2s plus 4. Now note that you made a substitution. The substitution you made is, this is 2s plus 4. Of course you know that there is ds here. ds all over s squared minus 4s minus 1. But you said let u be equals to s squared minus 4s minus 1. So we can come here, erase this, and put under here, put u. Now this becomes integral of 2s plus 4 all over u. Now our ds is what? Du over 2s plus 4. So in place of ds, we can put in this du all over 2s plus 4. So this becomes times du all over 2s plus 4. 2s plus 4 cancels 2s plus 4. So what are we left with? You are left with the integral of 1 over u times du, or the integral of 1 over u du. 1 over u du. So at the end of the day, what are you going to have? When you integrate 1 over u, it will give us what? Ln, or the natural logarithm of the absolute value of u plus c. And this becomes the natural logarithm of what is our u? Our u was s squared plus 4x minus 1 plus c. And that is the answer to that question. Okay? Natural logarithm of s squared plus 4s minus 1 plus c. Okay? Now let's look at the next question. The next question says integrate this. Integrate sin x all over cos s ds. Now how do you integrate this? Now you're going to integrate this by saying let u substitution be equals to what? Cos x. Let u be equals to cos x, and then differentiating u with respect to s, du all over the s will be equals to sin s. Whenever you differentiate cos s, if you differentiate cos s, it's going to give us sin x. If you differentiate sin s, it's going to give us cos s. Okay, so this will give us sin s. Now the next thing we are going to do is to make ds equal to the formula. So your du over ds is equals to sin s. Now this is over 1. Cross multiply. This times this is what? Du is equal to this times this is what? Sin s ds. Now to make ds equal to the formula, divide both side by what? Sin s. Divide both side by sin s. Sin s cancels sin s. Your ds is equals to du all over sin s. Okay, so at this point in time, remember that you made a substitution. So we have sin s all over cos s ds. Now remember that you said cos s is what? U. So in place of cos s, we can put u, and then this gives us sin s all over u times, what is our ds? We said ds is what? Du over sin s. Sin s cancels sin s, and this gives us 1 over u what? Du. Now I told you that 1 over u, integral of 1 over u du is what? Ln the absolute value of u plus c. Okay, ln of the absolute value of u plus c. And then finally, this will give us the ln. What was our u? Is cos what? X, and then plus c. And that will be the answer to this question. The next question. Now the next question says integrate this. Integrate s raised to the power of 3. Then we have s raised to the power of 4 minus 4 ds. So we have s raised to the power of 3 all over s raised to the power of 4 minus 4 ds. Okay, let me rewrite this. S raised to the power of 3 all over s raised to the power of 4 minus 4 ds. How do we go about profiling solution to this? We can start by saying let u be equals to s raised to the power of 4 minus 4. So our du over dx is equals to s raised to the power of 4 is what? If you differentiate this, it will give us 4s raised to the power of 3 minus 0. Because s raised to the power of 4 means 4 times s is 4x, then 4 minus 1. which is 4s raised to the power of 3. So minus 0. So du over ds is 4s raised to the power of 3. Now, to make ds subject to the formula, what do? We say since du over dx is equal to 4s raised to the power of 3, this will be over 1, cross multiply. 1 times du is equal to, this times this is 4s raised to the power of 3 dx. Okay, so our du will be what? Du is 4s raised to the power of 3 ds. So to make ds equal to the formula, divide both sides by 4s raised to the power of 3. This cancels this. Your dx is du all over 4s raised to the power of 3. Now, having gotten to this point, what do we do next? We write out the equation or expression again. So this s raised to the power of 3, then s raised to the power of 4 minus 4 ds. Now, knowing fully well that we say s raised to the power of 4 minus 4 is our u, so here we can put u, and then our ds is what? Our ds, this s raised to the power of 3 u times our ds is what? Du all over 4s raised to the power of 3. Why? Because we said ds is equals to everything here. So therefore, now will give us s raised to the power of 3 can cancel a raised to the power of 3. Okay, so we are left with integral of 1 over u times du over 4. Now, what would that give to us? Now, can we think this integral of 1 over u times can also be written as 1 over 4 times what? Du, right? Because 1 times du will give us du, 4 times whatever is under here will give us what? 4. So taking this one out of the integration formula because it's a constant, we have 1 over 4 integral of 1 over u du. So this becomes 1 over 4. Now, integral of 1 over u is the absolute value of u and there plus the constant c. This becomes 1 over 4. Then we have the natural logarithm of what is our u? Our u is s raised to the power of 4 minus 4 and then plus c. So that is the solution to this question. Okay, let's look at another question. Another question says integrate this. Okay, integrate this. Now, if you integrate this, let's bring it out. This is 4s plus 2 all over s square plus s plus 5, and then you have ds. Now, first of all, we have to make u substitution. Okay, so we say u is everything on the denominator, which is what? S square plus s plus 5. So your du over ds is s square is what? 2x plus s is what? When you differentiate s, it will give you 1 and then plus 0. Okay, differentiate 5, it will give you 0. Differentiate s squared, it will give you 2s. Differentiate s, it will give you 1. So our du over ds is 2s plus 1. Cross multiplying, this times this, it will give us du is equals to this times this will give us 2x plus 1 ds. To make ds equal to the formula, divide both sides by 2s plus 1. Okay, so 2s plus 1. So this cancels this, and our dx is what? Du all over 2s plus 1. Okay, now going back to our substitution, you know that the question given to you was 4s plus 2 all over s square plus x plus this s square plus s plus 5 ds. Now we already said that our s square plus s plus 5 is what? U. From here, u is equals to this, so we can put u here. Now our ds is this, so in place of ds you can put in this. Okay, so this gives us 4x plus 2 all over u times du all over 2s plus 1. Okay, now 4s plus 2 can also be written as 2 bracket 2x plus 1. Reason because 2 times 4s is 2 times 2s is 4s, and 2 times 1 is what? 2. So when you factorize, what is common here and here is 2, so you bring it out. 2 divided by 4s. Let me show you how I did it. What is common between 4s and 2 is what? 2, so we bring it out. 2 divided by 4s is 2x plus 2 divided by 2 is what? 1, all over. Then we have u times du all over 2s plus 1. Now 2s plus 1 cancels 2s plus 1. We are left with the integral of 2 over u times du. Now 2 over u can also be written as 2 times 1 over u du. Now if 2 comes out because it's a constant, you are left with 1 over u du. So this becomes 2. 1 over u is what? Ln, or the natural logarithm of the absolute value of u, and this gives you 2 times the natural logarithm of what is the value of u that we said is what? S squared plus s plus 5 and then plus what? Our constant c. So final answer to this question is 2s, or not 2s, is 2 times the natural logarithm of the absolute value of s squared plus s plus 5 plus what? C, which is the constant. So that's the solution to that question. Let's go to the next question.